Okay, so this is the first of our revision videos for our surds, indices and logarithms test, starting with review set 12A from page 352 of your textbooks. Now the first question is asking us to simplify 5 times the square root of 3 multiplied by 4 minus root 3 in the brackets. Now this is our first expansion rule, so we know that we have to multiply both terms within the brackets by the factor outside the brackets. Now using our surd rules, we know that when we multiply 5 root 3 by 4, the 4 can multiply by the 5, but the root 3 is going to stay the same. So we'll end up with 20 square root 3. We have a negative in the middle, so we'll keep that. Now we have 5 root 3 times root 3, and because we have the same numbers within our surd, we can multiply those together to get 3. And we get 5 times 3. So our solution is 20 square root of 3 minus 15. And always make sure you simplify these solutions as far as you can. Okay, our next question here, we can identify straight away as being a perfect square. So we know we're going to want to use our perfect square rule. So our perfect square rule says a minus b all squared is equal to a squared minus 2ab plus b squared. And in this instance, our a term is here and our b term is here. So to solve this, we're going to first have a squared or 6 squared, which is 36, minus 2 times 6 times 5 root 2. So the 2 times 6 gives us 12, times 5 gives us 60, multiplied by the square root of 2. And then our plus b squared at the end means we have to square the 5, 25, and square root of 2 squared is 2, so it's 25 times 2. So to simplify that out, we have 36 minus 60 square root of 2 plus 50. Now we need to identify our like terms here, the integers. So we're going to gather those together, and when they're gathered together, we end up with 36 plus 50 is 86 minus 60 root 2. Okay, our final question as part of part 1. We have 3 plus square root of 5 multiplied 3 minus square root of 5. So we can identify this straight away as our difference of two squares rule, where a plus b multiplied by a minus b is equal to a squared minus b squared. So our 3 will be a, and the square root of 5 is our b term. So we know that that will be a squared, which is 9, minus b squared, which is the square root of 5 squared. Remembering square root of 5 squared equals 5 minus 5. So the answer, 9 minus 5, is 4. Okay, in question 2, we're putting negative numbers to various powers. Now, we need to remember our rule that says a negative number to an even power here becomes positive, and to an odd power over there will become negative. So let's look at the first one here first. Now, our initial negative number is outside the bracket, so that's not going to any power, so that's going to stay there. Now, minus 1 to the power of 10 will become positive, and 1 to whatever power stays 1. So our answer is minus 1. Now over here, the negative again stays outside the brackets, but in this case minus 3 is going to the power of 3, which is an odd power, so it's going to stay negative. 3 to the power of 3 is 27, so it's negative 27, and we have a negative multiplied by a negative, giving us positive 27 as our solution. Now for this last one, we're using our index rules. Anything to the power of 0 is always 1. To a negative power means invert, put it as a fraction, so it's 1 over 3, and 3 to the power of 1 is just 3. So we can say that's the same as 3 over 3, subtract 1 over 3. 3 take 1 on the top line gives us 2/3. And that's our solution for that last one. Question 3, again, we're focusing on those index laws and how we combine similar base numbers with different powers. The first one here, we can also look at it as saying a times b, a to the power of 4 times b to the power of 5 times a to the power of 2 times b to the power of 2. And we can rewrite this if we want to, just to simplify it a little bit more, because when we're multiplying, it doesn't matter what order things happen in. Power of 5 times b to the power of 2. And we know when we multiply the same base numbers, we add the powers. So we have a to the power of 6 multiplied by b to the power of 7, and that's our solution. Now part B here, we are now using, we have a divide in the middle, so we can't rearrange the order. So we have, and I think it's easier to understand what's going on if we actually write it as a fraction. So I'll transfer it to 6x y to the power of 5 over 9x squared y to the power of 5 there. Now this helps as well because we can see that we have sort of those similar or like terms or base numbers all lined up above each other, so we can address them one at a time. So 6 over 9 is the same as 2 over 3. X over x squared, x to the power of 1 minus 2 is x to the power of minus 1, which is the same as 1 over x. Y to the power of 5 over y to the power of 5. 5 take 5 is 0. So that's y to the power of 0, which is 1. 1 over 1. So now we just multiply all along the top line and all along the bottom line, and we end up with 2 over 3x, and that's our solution there. Our final question here is combining a whole heap of different index laws. So first of all, we need to expand out the brackets on the top and the bottom line. So the 5 is outside the bracket, so that doesn't change. X squared, so our factors to the n power rule says that the two factors are both put to the power, and when we have one power put to another power, we multiply. So x 2 times 2 is 4, and y 1 times 2 is 2. Now on the bottom line, the 5 is inside the bracket, so that's going to be squared first. 5 squared is 25, and the x squared, 2 times 2 is 4, so it will be x to the power of 4. So we can note now that we have x to the power of 4 on the top line and x to the power of 4 on the bottom line. And we can either go through that x to the power of 4 or 4 minus 4 is 0, so we're left with x to the power of 0, or we can just cancel them out because we know that they're going to be equal to 1. Now, we know that 5 over 25 is the same as 1 over 5. And y squared here, there's no corresponding or related term on the bottom line, so we're just left with y squared over 1. So when we multiply across the top and the bottom, we're left with y squared over 5. Okay, so that's the end of your first video from review set 12A. We'll continue in the next video.